Hello guys, in today's video we'll be solving this question, that is minimize the heights. It is a medium level question as per GFG, but I guess it is not that easy to be put under this category, and the accuracy percentage is a very solid indicator of that. Accuracy with just being 15.06 percentage out of over of like 5 lakh submissions. So let us read the question. Given an array ARR denoting heights of n stars and a positive integer k, for each star you must perform exactly one of the following operations. We can either increase the height of the tower by k, or we can decrease the height of the tower by k. Okay, so at the end, after doing all such things, there is uh, no other rules as such. Which we can just increase. So we can also increase the height of all the towers as k if that brings us to the maximum answer, like the minimum possible difference. And we can either decrease them or we can do it in any order. There is no rules other than these two as such. So find out the minimum possible difference between the height of the shortest and the tallest tower after you have modified each tower. Okay. After you've performed operations on all these n towers for that matter, you can tell us the minimum possible difference. You can't find us like, okay, fine, we can find a slightly modified problem here. Note, it is compulsory to increase or decrease the height of k by k for each tower after the operation. The resultant array should not contain any negative integers. So what is the modified problem? Given an array denoting, okay, you have to modify the height of increasing or decreasing them by, okay, so in this we can either decrease or the height of the shortest. Okay, given an array, oh, you have to modify the height of each tower either by increasing or decreasing them by k only once. Okay, we can do this k thing only once. Yeah, we'll solve a tougher version of this. We can do that any number of times. So we'll start that. See, initially we have to sort the array, and people ask me how do I get that intuition of sorting the array at times, because every time it is not that easy. And after seeing the accuracy, I understood that this requires a bit of थोड़ा सा uh, good level of understanding of the question, and the you know your approach should be very, let's say, polished for you to solve this question. So I went here and I saw this time complexity thing. This is a very solid indicator that we should sort the array first. So that is what we are going to do. We will sort the array first, and what we'll do is we'll take this int difference. See, now if we have sorted the array, the smallest element is the first one and the largest element is the last one. So we can see, because that can be a possible answer. But this is not the only answer, because in this case, for example, if we have 1, 5, 8 and 10, if we have 1, 5, 8 and 10, we have now what we have done is our difference variable stores the difference of the largest and the smallest element. But is it the, what do you say? Is it the minimum difference? No. We can have minimum difference because we can add k, right? And let's say the k value here is 2. So we can add 2 to it and make it 3, because we are approaching this towards 10, right? We are 1 is here, 10 is here. We are trying to squeeze them together so that the value, since it is this big now, we have to decrease it to this much or this much for that matter. So we have to push this 1 towards 10 and push this 10 towards 1, right? So how can we push 1 towards 10 is by adding that k, and how can we push 10 towards 1 is by subtracting that value. So what we'll do is add 2 to this and we'll make this 3, and we'll subtract 2 and we'll make this 8. Now the maximum value is 8. Yep, we have two maximum values and the minimum value is 3, and 8 minus 3 is 5, so the answer is 5, right? But then this was the case when we just had to, at the highest terms we subtracted and we got the answer. But there can be a possibility, right? Had this been 4, had this been 4, so there can be a possibility that if we, like by default I'm telling, had this been 4 and this been 10, if we would have added 2 to this, it would have become 6, and if you would have subtracted 2 from this, it would have become 8. Okay. Now is 6 the minimum value? No, it is not. No, it is not. So here we by default, like we made this case like this is the base case for us. I mean we are telling कि इतना तो होगा ही. उसके ऊपर we'll see what happens, but this is the thing which will be the answer for sure. There will be one answer for sure, right? And the only case when there will be no answer when we have less than 2 elements, right? So we'll put that base case here. If n is equal to 0, like n is equal to 1, then we'll return that element itself. What is it? Array of 0. So fine. So I mean this case is also not required for we can remove this case, but then that is what we can. Okay, fine, we can take care of one element, but then while using the loop it will take care of it, so we do not specifically put this as a case. So that is what 65887. Now the minimum value here is 5 and not 6. The minimum value is 5 and the maximum value is 8, so 8 minus 5 is 3, right? So there can be a case where the middle elements, right, middle elements can be the maximum and the minimum elements. So not this middle elements, any two middle elements. So that depends on the case. So this is the base case that we have taken. Now what we'll do is we'll have this traverse this from 1. I'll tell you why I'm traversing it from 1. Because I'll do a minus 1. We are doing something like a of a array of I minus 1. So I minus 1 should be a valid index. So that is why. So we'll first make two variables mini, which will initialize with int max, and maxi, which will initialize as int min. Having done that, what we'll do is mini will be minimum of it can be 0 plus k, because in the middle minimum most element we are adding k, and for all the other elements a of I if a of I minus k, right, for a of, yeah, this is what the mini will be. Mini will be the minimum of either the smallest element, since we have sorted the array, smallest element when added with k, or the other element, rest of the elements subtract, because rest of the elements will be, because we are starting from 1, we are starting from 1 only, right? So except 0 case will be we are adding, because this is a minimum actually. So this needs, this is already minimum, so we need to support the other part of the array, right? So we are adding k to it, and for this we are subtracting k from the rest of the elements. And similarly maxi is equal to max of, but we'll do subtract, this is the highest element we are having. I will tell that since you are already highest, we'll take something from you because you are already highest. For the rest of the elements, I minus 1 minus plus k, we'll do plus k. This is how it works. But then there is a case when a of I minus k can be negative, right? And we have to exclude all such cases. So what we'll do is we'll take, if a of I minus k is less than 0, we will tell that no, we do not have to take consider this case, so we'll continue from it. And after each iteration, yeah, wait. After each iteration, we'll modify min by if it is this base value still the base value, or is it the difference between maxi and mini, and this will update that after each iteration, and will simply return difference. This is what the simple approach of this question is. Okay, fine. Array now. Yep, array. Why we have done this, you would have known by now, because see we have to find the minimum element, right? So a array of 0 is already minimum because we have sorted this array. Now minimum we have to add something, and for all the other elements, since this is not minimum, this is minimum, so we are taking something from it. You are god gifted, you are already minimum, will add to you. Now maximum will take from you are god gifted, you are already maximum, will take something from you, and for the rest of the elements, since they are not god gifted, will add them, something like that. So that is how it works. Oh yeah, again here also we have to mark array. Yep, int I is equal to 1. It was not that easy a question, but I hope you would have understood the approach, and that was all for this video. Until next time, thank you.